Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from weatherrisk.com here in Central Virginia. You're a captain of chaos, you're a colonel of confusion, you're a captain of catastrophe. And let's talk about This Week in Weather, and there is so much to talk about. I wanted to get this video out at 10:30 this evening on the Tuesday, but as you'll see, there's like 40 slides here, and there's so much to talk about. I want to make a complete presentation. There's a lot. I could have put in a lot more here. Believe me, there's a lot going on. So let's get right to it. All right, first, we're going to talk about some new teleconnection charts here for you to take a look at. Teleconnections are the jet stream, patterns and configurations like the Arctic Oscillation, the AO, the NAO, North American Oscillation, the EPO, the Eastern Pacific Oscillation, the PNA, and so on and so forth. We'll also talk about a possible Saskatchewan screamer. That is a type of clipper. It's not an Alberta clipper, but it's similar, but it's not quite that. There are three types of clipper systems. There's the Alberta clipper, the Saskatchewan screamer, and the Manitoba mauler. So those terms were developed by the great weather historian David Ludlam, I think back in the 1960s and 1970s. Anyway. So we'll talk about that. But sometime around December, I think December 6th, a real possibility of something blowing up off the coast. The Arctic Oscillation, the NAO, North America Oscillation, looks like it's going to stay negative for most of December. That's quite significant. There's a lot of potential here, December 15th and 30th, which looks good for eastern U.S. winter storms. But that's assuming the Pacific jet slows down. Okay? We don't know it's going to slow down. Some of the data suggests it's going to, but we don't know that yet. Okay, and then there's also a new long-term signal, which looks really great for the heart of the winter season for the eastern third of the country. And by heart of the winter season, I mean January, February, and March. Okay, so just want to let you know that this is my website here. I do a lot of private forecasting for commodities and for people who do operational weather concerns such as construction, landscaping, snow removal, ski resorts, vineyards, that sort of thing. And of course, you can see me on the my new Twitter page here. I have another one, Weather Risk Grains, over at Twitter, but that's just for agricultural stuff. So I separated them here. This is the snowstorm page, and then of course I'll have this over here on Threads, in case you haven't seen it. There's the Threads page, and a lot of people don't like using Twitter, and I understand that. So here's the Threads. You can see the stuff here. And there's the snowstorm page over at Twitter. There you go. Okay, let's get to it and see what's going on. So this here's the upper air map here as of this Tuesday, Monday night, Tuesday morning. There is the monster trough that came in with the very cold air here. Nice ridge on the west coast. But look at this system here off the California coast and this big upper low here in Alaska. These two systems are going to come into the west coast and change the pattern here. But this is a pretty impressive cold blast here. And these are the min temperatures on this Tuesday morning in the Northeast. So 28 here in my area near Richmond, but you can see there were teens in Ohio and western Pennsylvania, and then a lot of 20s. Notice that eastern New England the cold air hadn't reached there yet. You notice the temperatures here, still in the 20s and 30s here, much colder back in here. But all this here is getting into New England tonight. Here's the north central area, the upper Midwest. Yeah, sub-zero. They don't have snow on the ground here, folks. In Minnesota, they don't have any much snow. I don't think they have any. Or Iowa, and they've still got around zero. So that's pretty good for November. That's a blast of cold air, no doubt about it. This is the deep south. So the cold air did get into the southern states, so that's nice to see. And the good thing about this cold blast is that it's got people thinking, okay, winter's coming. When you don't get these cold blasts in November, like the last couple of years with La Nina, we've had these mild Novembers, people don't get ready for it. So this blast here in November is like, okay, wait a second, winter's coming. I really feel this one. This is not just a chilly autumn day. This is a winter day. So winter's coming, so I got to do things and get ready. Okay, and then this is southeastern states, and then this here is the central Midwest. You can see again. A lot of teens in Kansas, Missouri, pretty impressive. And then into central Illinois as well, Indiana, and 20s down into Oklahoma, northern Arkansas, western Tennessee. Not too bad. All right, this here's a new thing which I've developed. I'm going to blow it up here a little bit. So these are different terminology which I'll be using over on the website, the Facebook page, and over here on the snowstorm page, both on Twitter and on Threads from time to time. So this is a SECL. It stands for Southeast, Significant Eastern U.S. Low, SECL. See that? Not Southeast U.S., Significant Eastern U.S. Low, SECL, somewhere east of the Mississippi River. Then there's the SEX, which is Significant East Coast Snowstorm. Everybody wants SEX on the East Coast. Well, obviously. And then there's a MEX, Major East Coast Snowstorm. There's a HEX, which is a Historic East Coast Snowstorm. Then there's a SOVL, which is a Significant Ohio Valley Low. Usually that's rain for the East Coast. Okay, there's a SOFIS, which is a Significant Ohio Valley Snowstorm. And there's a SIML, which is a Midwest Low, and then a SIMILS, which is a Significant Midwest Snowstorm. So there you go. These are different terms I'll be using from time to time. All right, let's take a look at our MJO first and see what's going on here. This is the MJO for the next 2 weeks. GFS, Canadian, European. It's all in phase 2 right now. You can see here phase 2. And then the red line and the blue line, okay, and the purple line. So this takes us to December 12. You see these? All these models going to December 12. See this? So phase 3 and phase 4, like I mentioned over on the Twitter pages and over on the threads, when the MJOs in phase 3 and 4, it warms up, you get rain on the East Coast, and that's exactly what's going to happen. Now, but when you get into mid-December, all the models take the MJO into the neutral circle. And it looks like it might be headed towards phase 8 or phase 1 in late December. But we'll see. We don't know that yet. But that's speculation, but we'll see. Let's take a look at our teleconnections. These are the 4 teleconnections. Here are the 2 on the Atlantic side, the Arctic Oscillation and the NAO, the Greenland Block, and the Pacific side. You can see PEP, Eastern Pacific Oscillation, the Alaskan Ridge, Alaskan Low, and the West Coast Canada Ridge, PNA. So if we look on the Pacific side first, here's the EPO. There we are, the black dots. You can see us where we are right now. We're near neutral. We were negative. Now it's going positive. Now when the EPO is negative, that's when you get your cold air. So this produced the cold blast we had. But when it goes positive, that's not good for cold air in the eastern U.S. This means the EPO is gone. A ridge, upper low, has moved into Alaska, and that shuts off the cold air flow from Alaska. So when it stays positive, kind of goes neutral again by mid-December. Here's the PNA pattern. So we were kind of positive. Now we go briefly negative here in December with this energy coming to the West Coast. Then we go positive and go neutral again, back and forth. So the PNA is kind of back and forth here for the next 2 weeks till 15 December. Okay, well, let's take a look at the Atlantic side, the Arctic Oscillation and the NAO. But before we do that, I forgot to put these tables up here. Here's the long-term trend for the EPO. And you can see now the yellows and the oranges represent positive values. So the EPO stays strongly positive right through December 10th. Look at all the positive values here. There is some hint it's going to go negative again by mid-December, but a lot of it's just neutral. On the PNA, here we're slightly negative, then we go slightly positive, and then we're kind of mixed here on the 11 to 15 days, some negative and some positive. All right, on the Atlantic side, here is the Arctic Oscillation and the NAO, and both, notice that all the models have the NAO and the Arctic Oscillation and NAO, the Greenland Block, staying negative. You can see very clearly negative all the way through. Now it approaches neutral towards December 15 a little bit. So I don't know if that's really going to be the case or if the model's just, regressing to the mean here. But it's definitely neutral, a negative here for the next 2 weeks. And we can see that in trend. Look at the negative numbers here. Wow. Okay, Arctic Oscillation, constantly strongly negative right through December 9th or 10th. See that? And then even by the middle of the month, it's still a lot of negative indications here. The same with the NAO. Now, again, after December 10th, kind of goes neutral here, but very strongly negative the first 10 days of December, both of these. Also, the European extended model have come out with their new polar vortex flow. That's what I'm trying to get out here. And you can see here, the thick blue line is the mean. So the way to read this is these different blue lines, these are all different model runs. There's 50 of them in the European ensemble, right? And when the polar vortex is weak, it means that the winds are very weak, near neutral. And you can see the blue line comes down, 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 all the way into January. This is a weak polar vortex. Last winter and the winter before, this thing was way up here, very strong. And when you have a strong polar vortex, that means you don't get cold air outbreaks, and it's hard to get snowstorms on the East Coast, and all the cold air remains trapped up in Canada. So weak polar vortex means the Arctic Oscillation can come south, and or it can be quite negative, and that's good for snowstorms if you like snowstorms and cold. Okay, here's the GFS extended showing the same sort of thing. This is from Tomer Berg, his great website, and you can see here again the black green line is a negative, is the ensemble mean, and look, it's definitely clearly trends negative after December 12th or 15th, going into towards the end of the year, clearly going negative. So these are in very good agreement here. Okay, so let's take a look at our upper air patterns here. So here's the 1 to 5 day. This is for November 29th to December 3rd. And you'll see that the 50-50 low is an open wave here. The Arctic Oscillation is negative, the NAO is negative, the EPO is positive, the PNA is negative, almost strongly negative, actually, when you think about it. And the MJO here is hostile. You can see neutral phase. You can see that. It's in phase 3, which is a hostile phase, not favorable at all. Okay, let's take a look at the different terms here. So let me get rid of that. That's wrong. All right, so here is the Wednesday. And like I said, so here, remember we had this huge trough here on the East Coast, right? Now look what happens to this trough. It goes way up here in Canada because this energy is coming in to kicking it out. See, this energy comes in and this gets kicked out. Let me show you what I mean. Here you go. The energy is getting kicked out. Now look at the huge block in Greenland. This is the negative NEO we're talking about. This is a monster block in Greenland. This is very, very important. We'll talk about that later. So here comes the energy. This piece of energy coming out of Alaska, the one that was off the California coast, is now bringing rain and mountain snows to the southwest, southern California mountains in the southwestern states, into the Rockies, and more energy coming in. Look at this stuff just bombing out of Alaska. This piece of energy goes here to Missouri and develops a significant rainstorm for the deep south and into the Ohio Valley, the Appalachians, and maybe some rain to the mid-Atlantic and New England on Friday. We'll see that. And here's the surface maps. There's the low, a very nice low. Oops, bring this front. Here you go. There's the low right here. Sorry for the clearing the throat here, but it's very dry in here. And you can see the high pressures off the coast. So what happens is you're getting southerly winds around the high plus the flow from the moisture coming in from the Gulf of Mexico. And that produces significant rain. So this is a Friday morning, and then Friday afternoon, evening. Some of the models have the rain breaking up in North Carolina, Virginia, but it looks like a moderate, decent rain event. Heavier west of the mountains, clearly. All right, so this is now Saturday night. Now look at the energy coming in here. So look how this pattern changes completely from this to this. This is where we are, and this is Sunday. Yow! That's a big change. All right, so here's your block in Greenland. That's still there. See, but look at this monster trough here. See all this energy coming in? This is classic El Nino. Classic power, blasting fire hose Pacific jet, right? So there's one piece of energy here. That's the next big low pressure system. Another one here, another one here. And the ridge, look at the ridge developing on the East Coast with the warm air, mild air coming up. All right. What happens here? Well, there's another rainstorm. This is the one for December 3rd. Coming out of the southeastern states, late December 2nd, 3rd, comes up the East Coast. Low pressure moves off the East Coast here. A little bit of a secondary low, kind of a clipper system coming into the Great Lakes. So that's December 3rd. Okay. Now, this is now December 4. There's your huge block in Greenland and northeast Canada. It's still there. We have a bit of an ocean low here in southeast Canada, 50-50 low, right here. And this piece of energy has to go underneath the block. You know, normally when you see something like this, you think all this is going to go straight across the Midwest, okay? But it doesn't. What happens is this energy has to go underneath the block. It's got to go dig down underneath it. It cannot go into it. It's got to pass underneath it. That's what happens here. So the energy goes underneath it, here you go, right here, as you can see, okay? And we end up getting another clipper low, which moves from Michigan into New England with some moderate rain, jumps off the coast. And again, you can see the power of the blocking feature. Now, this system is going to go up into southeastern Canada. And then this piece of energy is going to become a problem. I'll show you what I mean. So the lot moves here to southeast Canada. Let me blow this one up so you can see it a little more. There you go. And you can see there's your system here. You can see it right here. There's your 50-50 low. This system here was the one here where the arrow is. So this is now Tuesday. And this system is dropping down underneath it. Again, we have a blocking pattern here, and your 50-50 low is here, which is forcing this system to drop south. That's why when you have a negative NAO and a 50-50 low, you get big winter storms on the East Coast. This is exactly why. There's your ridge in the Rockies, which is ideal. That's exactly where you want to see it. This system is forced to dig down, and sure enough, what happens is, let me shrink this map down, you can see it. Look at this system go boom. This is the European from today on this Tuesday. Look at this system bomb out here. Holy crap. If this was late December, January, February, I would be going bonkers. Okay, this is a very promising sign for the winter to see something like this in early December. All right, and if we look at the surface map, here is what the European does. Early, the European has on December 5, this is Tuesday night, a clipper low dropping down, okay, high pressure to the north. I'll go through Virginia, West Virginia right here, moderate snow in Pennsylvania, snow mixed in Ohio, western Maryland, and then the system goes off the coast and goes kablooey, explodes off the coast. And you got snow in Pennsylvania and New Jersey and maybe New York City. And then maybe rain changing to snow in Baltimore, D.C., and Connecticut. This is a nice system here. Now, this system is flying off the coast, don't get me wrong, but it's very nice. And here's the, again, you got to love that map. That's just, heck, that's a nice looking map, okay, for an El Nino pattern snowstorm. That's really nice. Here's the 18Z European GFS. It does the same thing. Now, the GFS is a little warmer, okay, because the low bombs out off of North Carolina, not off of here, but it's the same general idea. The same general idea. Again, December 6th. This is a Saskatchewan screamer. Why do you call it that? Because the system came out of Saskatchewan. It came out of Saskatchewan right there. Saskatchewan screamer. You got to love those babies. Those things are nice systems. Okay. Longer term, what happens here is this is our different Atlantic regime. So here's our positive NAOs, the blue. Our blocking is the red. Negative NAO is the green. So we want to see the red and the green areas. That's what you want to see if you like winter storms. And then the purple is Atlantic thumb ridge, which is not great for us, and gray is no blocking. So what happens is right now we're in the green. See, negative NAO. Now, once we go into mid-December, December 16th, 17th, we have some blocking, okay, but it's not a negative NAO. It's a split between a positive NAO and blocking in the North Atlantic. And then once we get to the end of the year, the NAO starts coming back here a little bit. That's what this is showing. Now, the other problem is this. Now, this was, take a look at the date here. See the date? November 24. You see that? Now, this is valid for December 12th. Look how promising this extended European has. Nice ridge on the west coast. All right? Moderate trough here. Cold air, some blocking in Greenland and northeast Canada. This looks like a nice early season winter storm. Maybe rain on the coast, snow inland, that sort of thing. Ohio Valley, Midwest, New England. Okay, fine. The problem is the updated maps for December 10th, and then this was December, let me get the right map up here. That's December 10th, and then this one is this is December 13th. Now what's changed here is we're still getting all this energy coming in from the Pacific. You see all this negative blue color here? This is a negative anomaly. All right, we're still getting energy coming into the western United States or something like we have a ridge here. That's not what this was showing at all. What's happening is that as we're getting closer to it, the models are still seeing the Pacific jet coming in. So it's a lot of uncertainty here. This is December 15th on the GFS extended from this morning. Now from this morning, oops, no, that's not what I wanted. Go back to here, you can see here. Yeah, we'll take this, just cut it out like this, and then we'll go here. So here, Okay, we can see the GFS from this morning. This is early on Tuesday morning. Look at the negative energy coming in here. There's no ridge on the west coast at all. There's no ridge at all. This is just howling Pacific jet energy. But the 12Z GFS extended has a ridge again. So we're seeing a lot of inconsistency here, a lot of inconsistency. That's the point I'm trying to get across. This does not match this. They're not even close. So there's a lot of inconsistency here. And then here's the European, okay, valid for December 10. Now remember, this was the European from November 24, valid December 11th. Here it is, December 10th. Again, look at howling Pacific jet crashing in here. Strong ridge. Now we still have blocking in Canada, but this is a classic example. Just because you have a negative NAO, Greenland block, okay, you can still have a West Coast trough. Here we have a positive EPO, big trough in Alaska, and a negative PNA, trough in the western United States. And you have blocking. So you see, you can have both. You have to look at the entire pattern, not just the Arctic oscillation, not just the NAO. That's what I'm trying to get across here. This is storminess. Big systems in the western United States bring a lot of winter storms here in December. There's going to be a lot of snow for the Rockies early on. Okay. Now, longer term, this is now December 25. Here's the extended European. Nice low here in the deep south, strong ridge on the west coast, cold air coming south. This is Christmas Eve. This looks like a snowstorm for a significant portion of the eastern U.S. If this is right, we don't know if it's right. The problem is, okay, that's the European. Here's the GFS. See it? They don't have that at all. They have a trough on the east coast on Christmas Eve, but there's no ridging. Very little ridging. So this might be snow, let's say, for the Appalachians or the Ohio Valley, but this is rain on the East Coast. So these are very different. I don't know which one's correct. I have no idea. I'm just pointing out the differences here. Part of the problem is that the models are having a lot of trouble handling the Arctic oscillation. This is from World Climate Service. Okay, they do great work here. They posted this on a Twitter page, so I'm using from them. Making sure you understand this is from World Climate Service. This is from November 18th, November 21, November 24. Early on, okay, this is the 45-day Arctic oscillation forecast. See the AO staying positive all the way through. Look at all the blue lines, the middle, way above the positive value. This is November 21, dropping down towards neutral. And then here, November 24, negative and then staying neutral. So this thing is evolving. This thing is evolving. That's the point here. Now, longer term, here's the MJO week 3 and week 4. Here's the European and the Australians. The European turns a neutral circle and kind of hints that it wants to go to phase 8 and 1, but it doesn't go there. The Australians do. The Australians take into phase 8 in December by Christmas Eve. The extended GFS, same thing, phase 8, December 17th through the 24th. Okay, and the CFS, almost to phase 8 as well, by Christmas week. Now, why is that important? This is why it's important. Phase 8 in December, okay, very cold. Not so much precipitation, but a lot in the deep south, which can get up the East Coast, but we don't know that. And then phase 1 is also pretty wet, eastern U.S., and it's also pretty cold. So that's why it's important. Finally, this is from Eric Weber, who's the climatologist in North Carolina State. And you can see here, he wrote this a couple days ago, can the early winter December North Atlantic block, negative NEO, have clues about mid and late winter, January, February, March? The answer is yes. In fact, the December and January, March NEO is significantly and positively correlated with each other over the last 50 El Nino events since 1855. So what he's done is he's looked at all the El Niños. See this? 1855 to 2015. December NAO, negative NAOs. Do they match January, March? Do they tell us anything about January, March? And they do. Generally means that during an El Nino winters like this one, the more negative the NAO is, the more negative the NAO is likely to be in January, February, and March. Very, very strong values here. You can see the values. Look at this. Here's the blocking. Okay, the red's up here. 0.5, zero point 0.6, something like that. Very strong correlation. And if you look at it here this way, this is my last slide. This is important, December 500 millibar anomaly correlations. December and what it means for January, February, March. When you have blocking in December, you have really high correlations here for the negative anomalies. You can see it in Greenland and Northeast Canada, really, really strong. And then you can see the surface pressures as well. Very hot, strong high pressure in northern Canada, troughiness on the east coast. So this is a really big, strong signal here. I think it's very positive. Also derive home the point, one other point, we have never had a block with a super strong El Nino or strong El Nino in December. We've never had it. I think we might have gotten close in December 2009, before in that winter, but I don't think it was nearly this strong. That was the only El Nino out of the 9 strong El Ninos and the 3 super strong El Ninos. That's the only time this has ever happened. So this is a rare event. It's quite significant, and it ends up supporting my claim that this is not a normal El Nino. Okay, that's the presentation. I hope you enjoyed it. I know it was a lot, but I like to be thorough. I guess I am too thorough sometimes, but there you go. This is meteorologist DT from Weather Risk. I will see you over on the Facebook page, the website, the Twitter page, and the Threads page.